All right, so here we begin chapter 8 on significance tests. So in chapter 7, they did not give us the population value. We were finding an interval where we thought the population value would fall in between. In chapter 8, we're going to be given a value, but then we're going to have this alternate viewpoint, right? And our idea is to see if we can find convincing evidence based on our alternate viewpoint to uh, reject the original idea or to fail to reject the original idea. My choice of words, you'll see, is important. So this section, the idea of a significance test, very important. Okay, there's an activity to start this to get you used or thinking about this idea. So go to the activity and then come back to this this set of notes. Okay, so you've returned objective 1. Here we're going to talk about these hypotheses for a significance test about a population parameter. So when you do a significance test, what you're doing is you're trying to use observed data to decide between two competing claims. These two competing claims can be called hypotheses. So there's two hypotheses. Both of them are going to be about the parameter. And again, typically it's proportion or mu. So it's about the parameter, right? It's about the population. The first hypothesis is called the null hypothesis, H sub 0. The null hypothesis is the claim that we are trying to weigh evidence against, right? We're trying to find evidence against this claim, all right? The alternative hypothesis, H sub A, is the claim about the population that we're trying to find evidence for this claim. Okay. Now there are two types of alternative hypotheses. One is a one-sided. That's where the parameter is either greater than the null value or less than the null value. So it's either a greater than or it's either a less than. The two-sided states that the parameter is just different from, and when you say different from, we say not equal to. Okay. And you'll see in the next slide, I talk more about that. Okay, so again, when you set up your hypotheses, your null hypothesis looks like this: H sub 0, the parameter equals whatever the null value is. Your alternative hypothesis, H sub A, colon, whatever your parameter is, and either greater than or less than or greater than if it's a one-sided, or it's going to be a not equal to if it's a two-sided, and then the null value. And again, you'll see the null value in the problem. All right. Some cautions first. These hypotheses should express the hope or suspicion that we have before we see the data. Always do this ahead of time, right? In your scientific process, your hypothesis always comes before you collect the data. And then the hypotheses always refer to the population, not to the sample. So be aware of that. That's why we use the parameter when we're talking about these hypotheses. Okay. And again, remember, your population parameters are usually going to be P for the true proportion, or it's going to be mu for the true mean. All right, so be aware that those are the two symbols we'll use the most. All right, here we go. Example 1, where does the time go? For each of the following settings, state the appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. So it says, as a part of its 2010 census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes. That's all it takes. On the census form itself, we read, the U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers. We suspect that the time it takes to complete the form may be longer than advertised. So this is like a point of contention, right? Like I did the census this summer. It took like 5 minutes. Like I understand why people just don't do it, right? As the commercials say, it helps get you local funding. So again, but that's whatever. So first, let's talk about the hypotheses, okay? So hypotheses. So we're going to have a null hypothesis, and we're going to have an alternative hypothesis. Now, the question is, what kind of problem is this? Is this going to be a mean or a proportion problem? Okay. Well, if I look here, I don't see any percentages. I don't see any decimal numbers like that. So I think this is going to be a mean question. So we're going to think this is going to be mu. Now, for the null hypothesis, mu equals some value. And I think the idea is this 10 minutes. I think 10 minutes is the null value. 10 minutes is your null average. So that is the value we're going to put right here. They're saying that they think that it takes 10 minutes for the average household. This last sentence talks about the alternative. We suspect that the time it takes to complete the form may be longer than advertised. Longer. It may take more time than advertised. We think for the alternative that the actual mean is going to be longer than 10. So this would be a one-sided test. This is how you build your hypotheses. Okay? Put the notation, mean or proportion, find that null value, and then determine is it one-sided or two-sided. And now we need to talk about what the parameter is. Define the parameter. So mu is going to be equal to the true mean time, in minutes it takes for US households to complete the census form. And I'll throw in 2010 to complete the 2010 census form. That's it. Okay, so there's the start to our significance tests. Hypotheses, what the parameter represents. Okay, all right, next problem, or next part, I should say. Okay, same kind of thing. So according to the website sleepdeprivation.com, 85% of teens are getting too little sleep on school nights. Jamila wonders whether this result holds in her large high school. She asked an SRS of 100 students at the school how much sleep they get on a typical school night, and all 75% of the students are getting less than the recommended amount of sleep. Okay, so we need to write our hypotheses. So again, we always start off with the null and the alternative. Now, when I see this 85%, immediately I think of proportion. This is a proportion problem, right? For the null hypothesis, our true proportion is going to be equal to some value. Now, this is going to be this 85%. This 85% is our null proportion value, 0.85. I'll do 0.85 to be official. Now, some people might want to take the 75 and divide it by the 100 to get 0.75. This is your sample value, your sample proportion. We don't use that. Remember, when we build our hypotheses, we always talk about the parameter, so be aware of that. Now, what about alternative? Is it going to be a greater than, less than, or not equal to? Now, again, this talks about less than, right? You see this word less than, but this actually is not the correct words to look at. It's this sentence right here. Jamila wonders whether this result holds. Does this result hold in her large high school? That doesn't give you an inclination of greater than. It doesn't give you an inclination of less than. That is where the two-sided not equal to comes into play. This is a two-sided test. Maybe her school gets more sleep. Maybe her school gets less sleep. We don't really care. We just want to know that if it doesn't equal that. Okay? All right. And then we define what our parameter is. Our parameter is P equals the true proportion of all teens at Jamila's school, Jamila's high school, getting too little sleep on school nights. Okay, so this one was definitely tricky because of the wording. So do your best. Look for those words of is different than, does not hold for, that kind of thing when we're looking at two-sided tests. All right, great. That's objective 1. Objective 2 is coming.